Welcome to Learning Math with Mr. Tan. Today we'll be looking at how to use multiplication frame to expand quadratic expressions. But before we get to that, we need to first understand what quadratic expansion means. Alright, so if I have two algebraic expressions, one is x and the other is x plus 1, and I actually multiply them together, it is like finding the area of a rectangle of sides x by x plus 1 over here. Okay. Furthermore, I can actually break it down into a square of sides x by x, and then another rectangle of side x by 1. Okay, so if I were to go and find these two shapes part by part, meaning I find the area of the part shaded in yellow and the part shaded in pink, then I would actually be able to find the whole entire area component wise. So I would have x squared over here, which is obtained from x multiplied with x, and then I have in the pink area 1x, which is actually multiplying 1 by x. So if I were to combine these two parts together, it's actually equivalent to the whole entire area of the rectangle, which is actually x squared plus x. Alright. Another simple example to show to you over here would be this. Another rectangle, x plus 1 by x plus 2. So I have over here x plus 1, over here I have x plus 2. And I actually can break it down again into a square of side x by x, so that's x squared. Alright, another rectangle, 2 by x, which is 2x. Another rectangle, which is 1 by x, which is just plus x. And then lastly, another rectangle of sides 1 by 2, which is positive 2 after you go and multiply them. So if I were to go and combine them and simplify, I actually get this overall area. So what this multiplication frame is doing is going to be transforming this very visual method into something that is more efficient. Alright, you don't have to draw squares and rectangles because usually there's not a lot of marks awarded for this kind of questions, and you don't want to be spending a lot of time over this when you can actually do it really fast. So I'm going to show you how. Okay, so in this example here, I've already set up the multiplication frame for you. It is basically a hashtag. Alright, it's like a hashtag thing. And I put over here the multiplication sign just to remind you that you are later on going to multiply term by term. So what I'm going to do now is actually, alright, to consider in the left side bracket, there are two terms. One of which is positive x, the other one another positive 1, which is just put a plus 1 over there. So on the left of the hashtag, I'm going to put positive x plus 1 here. Alright, so later on you will have an example where there are negative numbers involved, and we need to put that in accordingly because the signs do change because of that. Alright, and then the bracket on the right, I'm going to put the terms over there, which is positive x and positive 2, into these two parts. Alright, so the terms in the bracket on the left, I put it on the left. Terms in the bracket on the right, I put it over here on the right. Okay, so I'm going to put in positive x plus 2 here, and then later on you're going to do what you see me doing. In fact, I've already done that in the previous diagram done for you to show you. What I did was to find the area of each shaded region. Okay, so transferring that over here is the same. I'm going to take the positive x multiplied with the positive x, which is going to give you a positive x squared. Alright, positive x multiplied with positive 2 is going to give you positive 2x. Positive 1 multiplied with positive x is going to give you positive x. Positive 1 multiplied with positive 2 is going to give you positive 2. Okay, so what you need to do, like what you did just now, in fact, if you notice the example here below, over here, all right, is actually the same as what I'm showing you over here. So what I did previously was to go and sum up all the individual areas of each parts, sum it up, simplify it, and then that's my answer. So over here is going to be the same thing. I'm going to take x squared plus 2x plus x plus 2, and that's going to simplify into x squared plus 3x plus 2. Alright, so the only thing I can actually simplify, I can actually combine, is actually 2x plus x. So you realize that what I've done is actually to transform this very visual method into something that is really very fast and efficient. Okay, so we're going to see in the next example how to do it efficiently. So let's look at example 2. Okay, I have broken it up into example 2a and 2b. Notice that for both these two examples, the bracket on the left have the same term. So I'm trying to keep as much things the same for you to focus on what I need you to be looking at. So what I actually need you to observe later on is the difference between these two situations. Okay, right now we have a new situation of there is a minus over here. Comparing to here, all the terms are just positive. Okay, so first I will still need to set up the multiplication frame. Okay, I'm going to stick with this color. Pardon me if you find the lines a bit wiggly when I can actually prepare beforehand the frame. I can actually use a ruler, but for the sake of the video, I'm not going to spend time on that. Alright, so I'm going to just draw the frames. Alright, and well, in exam, you don't really get any marks for aesthetic sense, so that's really fine. Alright, so multiplying. Okay, so I'm going to focus on example 2a first. And for example 2a, I have positive x minus 2. So positive x minus 2. And then on the bracket on the right, in the bracket on the right, I have positive x plus 3. Okay, and I'm going to multiply them term by term. Positive x multiplied with positive x is going to give me positive x squared. Positive x multiplied with positive 3 is going to give me positive 3x. And the next line, I have to be a bit careful because it's negative 2 multiplied with positive x. Negative number multiplied with a positive number is going to give you a negative number. So let's settle the sign first. And then I have 2 multiplied with x, which is 2x. Okay, and finally, negative 2 multiplied with positive 3 is going to give me negative 6. Okay, so again, I'm going to focus on this part, which is over here. I'm trying to combine all of them together to find the overall area in that sense. Before this expansion, I'm going to find the overall result after I simplify. Okay, so I have x squared plus 3x minus 2x minus 6, and then finally x squared plus x minus 6. Okay, so in example 2b, similar. On the left, I'm going to have positive x minus 2 here, and then on the right, I have positive x minus 3 over here. Okay, so let's deal with the terms term by term. And multiplying positive x with positive x, same thing, positive x squared. Multiplying positive x with negative 3 is going to give me a negative number, 3x. Okay, negative 2 multiplied with positive x is going to give me negative 2x. And then finally, I have negative 2 multiplied with negative 3, which will give you a positive number. 2 multiplied with 3 is going to give you a 6. Okay, so I have x squared minus 3x minus 2x plus 6. Okay, so finally, I will have x squared minus 5x plus 6. Now the beauty of this method is what we normally teach in schools is we teach students to multiply in term by term. Alright, by the time you get to the fourth term, which is -2 multiplied with -3, because of you seeing a lot of negative signs there. Alright, so perhaps, I'm just suggesting, perhaps for some people, cognitively they only think of the negative. So they will give the final answer as -6. Alright, when they should, your teacher would have said this, they should take the negative, multiply with the negative, change the sign into plus, alright, a positive. But because by the time you reach the fourth term, you have already done a lot of work, and then your focus is mostly on the multiplication and not the signs. So therefore, sometimes it's a bit easy for us to forget that. So therefore, using the multiplication frame, it allows you to focus really term by term, multiplying term by term, and getting the signs correct. Okay, so that's for example 2. The last one I will be looking at is example 3. And in example 3, I actually included the coefficient of x to be like 2 or 3, so what happens to them? Okay, not a lot different. So what we're going to have is we're still going to set up the frame. Okay, and I'm going to proceed to put in the term. So I have positive 2x here, plus 1, positive 3x, and then minus 2. So I will again multiply them term by term. I will have positive 2 multiplied by 3 give me 6, and x multiplied with x give me x squared. Alright, so if you're uncomfortable with that, what I would suggest is for you to look at the signs first. So positive multiplied with positive here, it's going to give you a positive. Alright, 2 multiplied with a 3 will give you a 6, and then x multiplied with x will give you a x squared. So I am going in this order. Let's first settle the sign, and then we will settle the number, followed by settling the alphabet, which is the unknown or the variable. So next we will settle the other terms. Okay, so positive multiplied with negative is going to give me a negative, and then 2 multiplied with 2 is going to give me a 4, and then that is x. Okay, and positive multiplied with positive, still positive. 1 multiplied with 3x is going to give me just, well, 3x. Okay, and finally a positive multiplied with a negative is going to give me a negative 2. Right, and my final answer would be 6x squared minus 4x plus 3x minus 2. Simplifying that would give me 6x squared minus x minus 2, so positive 4x plus, sorry, negative 4x plus 3x is going to give me negative x. Alright, so I would just want to make one final point. What if I multiply the other way around? Okay, so let me just make a side point here. What if I rearrange the two terms? The two factors. Okay, when you learn factorization and you are asked to, for example, factorize this, then the representation of the two brackets is actually representing the factors of that expression. So we'll get to that when it comes along. So if I turn the other two, the two brackets the other way around, what's going to happen is, well, multiplication is commutative, and what it means is, for example, 2 multiplied with 3 is the same as 3 multiplied with 2. So they both give you the same results. What's going to happen here is you still set up the multiplication frame. You should expect the same answer. And what you have is this 3x minus 2. And then I have positive 2x plus 1. So you're going to get similar things over here. So first box here will give you a positive 6x squared. So I'm going to go a bit faster. Positive 3x, negative 4x, and then negative 2. So what you will get is 6x squared plus 3x minus 4x minus 2. And what you will have in the end is 6x squared minus x minus 2. So two things here is, one, multiplication is indeed commutative even for in this algebra world. The other thing that we can take away from here is that see, we want to look at things from two sides. Okay, so what I mean is this: if I talk about this how multiplication being more of a potential pitfall for some people, then if I take the original example, which is this, and then I move around the two brackets and I actually get a new example which allows me to practice this multiplication of -2 with +1, then from one example I get two examples for me to practice this multiplication frame. So you could try for your practice questions to do this commutative switch and then again work it out using the multiplication frame. So I hope this video has helped you to gain a bit of understanding about how to use multiplication frame to do your algebraic expansions. I really do hope this helps you along with your studying of quadratic expansions. Thank you for watching, and do subscribe to my channel if you feel that this is helping you, and do stay tuned for the next video. Bye.